In this question, we want to solve the system of equations shown. In order to do that, we're first of all going to recognize that the x, y, and z are all in the denominator. So perhaps the easiest thing to do is to use the method of substitution. Let a equal 1 over x, let b equal 1 over y, and let c equal 1 over z. And once we do that, we can rewrite this first equation as 4a minus 2b plus 10c equals 3. The second equation is 3a plus 4b minus 3c equals 3. And finally 2a minus 6b plus 2z equals 5, or plus 2c equals 5. Boom. Now that we've got that, we can go about doing our typical matrix work. Let's get 12s in the first row, or excuse me, in the first column. Do our subtraction and revert this back to its original form. Revert the first row back to its original. Subtract row 1 minus row 2 and row 1 minus row 3 and get our zeros here. And once we have that, we can recognize that multiplying the second row by 15 and the third row by 11 we'll get entries in the y column that allow us to eliminate. So this is what happens when we do that. Adding row 2 plus row 3 produces a 0 value here. And now we can solve 828c is equal to negative 276. When you solve for c, you get negative 1/3. Plugging a c value of negative 1/3 into this row, negative 22b plus 42 times negative 1/3 equals negative 3, leads to a b value of negative 1/2. And if c is negative 1/3 and b is negative 1/2, we can take those up into the first row and solve that out. And we get that a is equal to 4/3. Well, since c is the reciprocal of z and b is the reciprocal of y, and a is the reciprocal of x, we can say that x is 3/4, y is negative 2, and z is negative 3.